All right, welcome back. Happy Monday morning or Monday afternoon. I hope you watched the little video that I sent about vectors. Just a little short clip I always use when we start talking about vectors. You probably have all seen it, but we are starting vectors today. So, with the wonderful Despicable Me little clip, let's write some definitions. First, vector introduced vectors to us, but let's go ahead and write down a definition. What in the world is a vector? Okay, he said it best. It's a quantity that has both magnitude and direction. Because he was committing crimes with both magnitude and direction. All right, so what does a vector look like? We're going to start with, what about the direction of a vector? This one's going to have several more definitions than we've had. The direction, let me go ahead and put of a vector, because you can have the directions of other things. Direction of a vector is the orientation of the vector. Which is determined by the angle the vector makes with the horizontal line. Okay, we will talk a lot more about that angle and the direction of a vector in trig, but just know it's the direction it's going for now. Okay, so that's one piece of our vector. Let's go ahead and talk about a few other things before we get into magnitude. A scalar, I don't know why they always put it here. When you talk about what a scalar is, it's not a vector. It's in contrast to a vector. Okay? It's just a quantity that consists of magnitude. Of magnitude with no direction. Okay, when you think of the word quantity, what do you think of? It's simply just a number. Oh, what am I writing? Okay, so we'll talk about scalar other things, okay, like scalar multiplication. It's just multiply it by 2, okay? So scalar is just a number, okay? I'm going to scroll down just a little bit as we get into more definitions. I'm going to go back to vectors of purple. So we talk about the initial point of a vector. If you have an initial of anything, your initials of your name. Okay, what are the initials of your name? They're the first letters of your name. The initial point of the vector is the starting point. Of the vector. Okay? Well, if you've got a beginning, would it make sense that you have an end? The terminal point of a vector. Because guess what? I forgot point up here. The initial point of a vector. The terminal point of a vector is the end point. Okay, so we have a beginning, and we have an end, the initial point and the terminal point. Okay, the beginning and the end, the starting point. And last but not least, we're going to define what is magnitude, because that's going to be the biggest part of our vectors. The magnitude of a vector. The magnitude of the vector is simply the length or distance. Can you read that? Let me go back. Let me try that again. Length or distance of a vector. Okay? We will symbolize magnitude something like this. It will look like absolute values, but that's going to mean the magnitude. When we do those absolute values, it means the magnitude. Okay? And the magnitude, there will be something in the middle. It will be like a little italicized V with almost a ray over top of it. Okay? So that will mean the magnitude of vector V. So it'll be a little V, italicized. That's probably not a very good italicized V. But this little ray part is a line with half of an arrow over it. Okay? That means vector. I'll write that out beside it. This stands for vector. Okay? Maybe not the... Let me take the parentheses away. I'm sorry. Okay. This is simply a vector. Okay? Now we're going to unpack this and we're going to look at some different things. How do we name a vector? Can we find the magnitude of the vector? Okay, so here's just definitions that are going to help us starting out. Okay? Vectors, in general, I'm going to put on a coordinate plane. Okay? Now, vectors don't generally have a coordinate plane drawn there, the x-axis and the y-axis. It's simply going to be a starting point. Here we go. I'm going to actually draw it the way it should be. Maybe I'll draw it the other direction. So, and we're going to have a purple vector. Okay? In general, there's going to be a dot on one end and an arrow on the other end. Okay? The dot will symbolize the initial point, and the arrow, where that is, it's not like it's going on any farther, but that is going to be its terminal point. Okay? And we can name vectors just like we name lines and just like we name other things, but it will just be one italicized letter. My italicized letters aren't very pretty, so there's my vector A. Okay? And if I wanted to write vector A, I would put a little A and I would do that little half ray arrow over the top of it. That would be vector A is how we would say that. Okay? And if I wanted to find the magnitude of vector A, all right, how would I write that? I wanted you to find the magnitude of vector A. I would draw the absolute value lines, and I would put a little A, and I would draw that beside it. Okay? And I would simply need to find what is the length of, or the magnitude, so this means the magnitude of vector A. Okay? So now we need to find the magnitude of vector A. How in the world are we going to do that? Well, you know I said that we didn't really draw an XY coordinate plane? But if we are going to draw one, we will always put the initial point at 0, 0, at the origin. Okay? So if I wanted to draw a coordinate plane here, I would put the initial point at the origin. Okay? It's where they're always going to be. Okay? So if I wanted to find the length from the initial point all the way to the terminal point, what is the length of that line? What might I do to find the length or the magnitude of the line? Well, could I possibly draw a line straight down at a right angle and make a triangle to find this missing length? Could I do that? Could I find how far it is up this? I can. 1, 2, 3, 4. It's 4 units up. Could I find the length going here? Oh yeah, 1, 2, 3, 4, 5. Okay. Guess what? You all guessed it. It's a right triangle, and I have 2 side lengths. Can I find the hypotenuse? I'm going to use the Pythagorean theorem. I would say 4 squared plus 5 squared equals c squared, even though I know I'm looking for a. That's okay. So I have 16 plus 25 equals c squared. Did I do 41? Is that 41? I don't have a calculator handy with me. I'm pretty sure it is. So c, or a, would be the square root of 41. And right now I'm okay, I'll take that. So I would say over here, the magnitude of vector A is simply the square root of 41. It's the length or the distance, okay? Could I have used the distance formula? Of course, Miss Evans, and without drawing the triangle. So I'm going to go back. I'm going to attempt to take away the triangle. Could I find, I'm just going to pretend that green line. I'll draw the blue line back, I promise. Could I have done the distance formula? Well, then I would have had to assign points, right? My initial point is still going to be 0, 0. Would I need to assign a point or a coordinate to the terminal side? Yes. So I would go over 1, 2, 3, 4, 5. And I would go up 1, 2, 3, 4. So this point would be 5, 4. Plugging in the distance formula, you should get the exact same answer. Okay? That's leading me into the next point that we need to have, a definition. Okay? The components form of a vector. Okay? The component form of a vector. The component form of a vector lists its horizontal and vertical change from the initial point to the terminal point. Okay? List So when you think of horizontal and then vertical, are those your X and Y axes? Yes, they are. All right. Okay, so it's initial to its terminal. I'm going to kind of recreate the one I just had up there, just on the other page. It started somewhere like this, and it went over something like that. It went over to 5, and it went up to 4, right? So the horizontal change from the initial to the terminal, horizontal change was 5. Vertical change was 4. So guess what the components are? 5, 4. It's going to look and appear a lot like a coordinate. But the difference with a vector are going to be, they won't be parentheses on the side. It will be the little alligator mouth, the greater than, less than symbols. That will be the component form of a vector. Okay, so you will have point. Sometimes they put a little A and a B, okay? So vector form, we could even say, is vector A. Vector A has components 5, 4, okay? Opposite vectors, next really good definition. When I say the opposite, what's the opposite of 12? You're right, negative 12. So an opposite vector, or opposite vectors, will have opposite components. So vector A up here, what are the opposite components of vector A? Opposite of vector A would simply be negative 5, negative 4. Because the opposite of 5 is negative 5. The opposite of 4 is negative 4. Okay? Are we okay with that? Yay, good job. Next, guess what? You can actually add vectors together. Okay? So if I have a vector, let's say vector Q, and it has components of 2, negative 1. Okay, you can have a negative component just like you can have a negative number or a negative coordinate. Okay, and I have vector, we're just going to say R, and it has components of 5, let's say 7. Okay, if I wanted to add two vectors, okay, we actually call that a resultant vector. I'll go ahead and define it. A resultant vector is just the sum of, let me look at it exactly. The sum, or difference of two given vectors. So the sum or difference, because you can subtract, the sum or difference of two given vectors. Okay, so I've given you two vectors. If I wanted you to add vector Q plus vector R, we would simply add the x's and add the y's. So really we would say 2, negative 1, plus 5, 7. So I would take my x's, 2 and 5, and that would be a total of 7. Negative 1 and 7, which would be 6. So 7, 6 would be the resultant vector of vector Q plus vector R. Okay, so this would be vector Q plus vector R. And you're done. Resultant vectors just mean you can add them together. Okay? If you want, we can look. Actually, it's really neat to see graphically how that works. Let's close that. I want to go to another page before I go to do that. So, if we have vectors, should I keep it the same? Vector 2, negative 1. Okay, there's the first vector. And then let's do the other vector, different color. And what did I say it was? Oh my goodness, I can't even remember. Sorry. 5, 7. Okay, now the thing is I can start from anywhere. So I need to go over 5, 2, 3, 4, 5, and up 7. Up 1, 2, 3, 4, 5, 6, 7. Okay, So here's my vector Q, and here's my vector R. Okay, I didn't go anywhere from the origin, but if I wanted, I could put each one of these at the origin. Okay, so if I wanted to draw and pretend I put Q first. Okay? I went over 2, I went down 1. Okay? Now, if I want to add vector R to vector Q, I can simply pick it up and put it at the end of vector Q. So now, when I add it, oops, I'm still on move stuff around. Sorry about that. Undo. Just undo it. Okay, sorry. My initial point with Q, okay, is where I'm starting. So I add Q. Okay, now my new initial point is at the end. The terminal point of Q should be at the beginning part of R. Okay, and from this point, I would go over 5 and up 7. I didn't really mean to end all the way at their top, but I did. Okay, the resultant vector would be this vector where we added them together. So we're going to pretend that ended at 0, 0. Now let's look. Did we get the exact same answer? I remember the answer, 7, 6. So from the initial point, this is Q plus R. That's my resultant vector. 1, 2, 3, 4, 5, 6, 7. Did we go up 6? So from the origin, 1, 2, 3, 4, 5, 6. So this is the vector 7, 6. We can put them on top of each other. That's just a little graph visual of what that looks like when you add vectors together. If I had another vector that was equal to either one of these, let's see if I can, never mind, I'm not going to be able to, so I'm just going to go recreate another vector that is equal length of Q. Okay, I'm going to do another one, equal length of Q. So Q is 2, negative 1. Each one of these is 2, negative 1. So if you see a vector and it asks you to give the components of a vector, okay, you're going to go to the initial point, and you're going to go over x's and down y's to give a component or a coordinate of where the terminal side is, okay? These two vectors that I just put up here both have components of 2, negative 1. Sorry for that extra little line, okay? They are the same, or they're equal vectors. I don't think we need a definition of equal vectors. They're vectors that have the same. They have the same components, they'll have the same magnitude, and they will have the same direction. Okay, well, maybe I'll do that. So they have the same components, magnitude, and direction. Those are equal vectors. Okay. I believe the last definition that we have is for scalar multiplication. Now, what was scalar again? What did I tell you? Right, it was just a number. Okay, so scalar multiplication of vectors. So scalar meaning just a number. Okay. It's going to be, it's easy way to add vectors is to multiply the vector by a constant, okay? So if you've got multiple vectors you want to add that are all the same, like we had Q, the 2, negative 1, so we had 2, negative 1, but we had 3 of them. What if I wanted to add all 3 vectors together? So this was Q. Now all 3 of them, I could say plus the next one, plus the next one, okay? Or I could take a scalar number, which is just, in this case, the number 3. There's 3 of them, times a vector. 3 times 2, negative 1 would simply be 3 times 2, which would be 6. 3 times negative 1 would be negative 3, okay? So 3 times vector Q would give me 6, negative 3. Pretty simple. Vectors really aren't that hard, okay? There is an application to vectors. What are you talking about, Miss Evans? Oh, this is actually a really neat application because have you ever floated down the river, been in an inner tube and just gone floating, let the current take you, okay? Crazy story, another time. My parents did this in the Tennessee River and had to swim and actually had to be picked up by somebody because they were on floats on the Tennessee River and got swept away from their boat. Their current took them very far. It was kind of funny. I mean, I wasn't there, but the story sounds kind of funny. But here, a rower on a lake is rowing a boat at a rate of 5 miles per hour. They're rowing. I personally don't like to row a boat, but whatever, they are. The current is moving at 2 miles per hour, the opposite direction, so they're rowing into the current. Even worse, not doing this. How fast was the rower traveling over the ground below? Okay, so they're rowing at 5 miles per hour. They're going into the current. Okay, wait, let's do this. So they're rowing in one direction at 5 miles per hour. So really we would say that would be a 5-0. They're only going in one direction, okay? They're not going up or down, that Y value, okay? The current is pushing back at them at a rate of 2 miles per hour. Now, back at them, they're rowing into it. You have to use a little thought because then they're going backwards, okay? It's pulling them backwards 2 miles per hour. Okay, so if I were to add these two vectors together, okay, and I'll tell you which one it is, the rowing example, okay? If we were to add these two together, we would find out how fast they're going. They're actually rowing and going, moving at a speed that is, if we were putting it in vector form, adding these two together, 5 plus negative 2 would be 3. 0 plus 0 would be 0. So they're actually moving at a speed of 3 miles per hour. Okay? It means you're not going near as far as you should be. Get on a different river or different lake. Okay? That's my advice. That's okay. All right. This is a small overview of vectors. I hope that you have gotten it. Ask me any questions that you have. Your homework from this lesson, from lesson 63. We're going to do the practice. And the numbers, let's see, 2, 3, and 5. Okay? All right, happy Monday. We'll see you tomorrow.